Because you'll probably be given the odd problems for homework, let's take a look at a couple of these even ones here for more practice on factoring by grouping. In number 44, I'm given xy plus xz plus wy plus wz. And what I seem to be able to do is factor out an x from the first two terms and a y from the second two terms. Let's see how that works out. On the first, let's see, we'll put x y plus xz plus wy plus wz. Alright, if I factor out an x here, for my greatest common factor from these two terms, I'll divide each one by x. Those x over x is 1, so I'm left with y. Positive x over positive x is 1, so I'm left with a positive z. And actually, what I'd like to do is show these in two different colors. Now from this, I can factor out the w, a positive w. And when I factor out a positive w, I can divide both of those by w. And those cancel to 1, and I'm left with again a y. And those cancel to 1, and I'm left again with a z. So notice I now have two terms, x times the quantity y plus z, and plus w times the quantity y plus z. So basically, I can divide out y plus z from both terms. I can divide out y plus z from that term, and I can divide out y plus z from that term because y plus z is my common factor. So those become a 1 when I divide out the y plus z, and I'm left with just the x. And these again become a 1 here. That's pretty strategic. We're doing that for the exact purpose of getting those factors. So we have xy plus xz plus xy plus wz. That factors to y plus z times the quantity x plus w. Let's take a look at the next one. Let's look at number 48. Number 48 says t to the third power plus 6t squared minus 2t minus 12. Now, part of the strategy behind factoring by grouping is that I see that my first group has a common factor, a greatest common factor, but it's different from the common factor of the second group here. So in the first group, I have a greatest common factor of t squared. That's the greatest number that I can divide out from t cubed and 6t squared. And when I do that, I end up with t plus 6. Okay. Well, in my second group, I have a negative 2t and a negative 12. Both of them are negative, so I can divide out a negative, and they're both even, so I can divide it by a 2. And when I do that, I'm left with, let's divide that by negative 2, divide that by negative 2. I'm left with a t plus negative to negative, but divided by a negative is a positive. 12 divided by 2 is 6. And so I now have two terms, and those terms share a common factor, and that common factor is t plus 6. And when I divide that common factor out from each term, when I divide out the GCF from both terms, I'm left with t minus 2. So number 48 in its factored form is, let's use the old commutative property and turn that around to t minus 2 times t plus 6 quantity. Alright, let's look at number 50, because that one's going to be a little bit more fun. Number 50 says 10a cubed plus 50a minus 15a squared minus 75. First thing I notice is that all of my coefficients here are divisible by 5. That's the first thing I notice. So I can at least divide everything by 5. That one has a cubed, that one has an a, that one has an a squared, that one doesn't have an a. So that's really all I can divide out. So what happens when I divide each term by 5? Well, let's see. 10 divided by 5 is 2, leaving me with a 2a cubed. And 50 divided by 5 is 10, and that leaves me with a positive 10a. Minus 15 divided by 5 is 3a squared. Minus again 75 divided by 5 is 15. Alright. Now here's where it behooves us to ask the question, is our polynomial prime, or do I have greatest common factors? At this point I ask myself, can I still factor by grouping? And it looks like I can. It looks like that the first two terms here have a 2a in common. And that 5 is still out there, don't forget about that. So if those two have a 5a in common, then I'm sorry, if they have a 2a in common, then I can divide that from both of those two, and I get 2a cubed divided by 2a is a squared. 10a divided by 2a is a positive 5. Okay, and that these two have in common a negative 3. I can divide out a negative 3 from both of them. So if I divide out the negative 3 here, I'm left with a squared plus 5, and that's not arbitrary at all. That was pretty strategic of us to notice that we have these greatest common factors, because it will hopefully have these common factors once we do our division. So in dividing out the greatest common factors, we decide that these two terms, oh look at that, they have an a squared plus 5 in common, and here's our 5 on the outside, don't forget that, that has to keep coming down. When I divide out a squared plus 5 here, I'm left with 2a, and when I divide out a squared plus 5 here, I'm left with minus 3. So our whole answer here for number 50 is going to be 5 times the quantity a squared plus 5 times the quantity 2a minus 3, and that is now fully factored into really all prime numbers. This is a strategy we're going to employ a lot when we are factoring trinomials, and that will be in the next chapter.